The modulus of rigidity for a material is 0.51 into 10 to the power of 5 Newton per mm square. A 10 mm diameter rod of the material was subjected to an axial pull of 10 kN, and the change in diameter was observed to be 3 into 10 to the power of minus 3 mm. Calculate Poisson's ratio and the modulus of elasticity. So here the modulus of rigidity or shear modulus. Modulus of rigidity is also known as shear modulus. So generally denoted by capital G. So here shear modulus or modulus of rigidity for a material is given. So how much? 0.51 into 10 to the power of 5 Newton per mm square. So shear modulus G is equal to 0.51 into 10 to the power of 5 Newton per mm square, and also given diameter of the material. So diameter of the rod, actually given diameter of the rod, D is equal to 10 mm. D is equal to 10 mm, and also given subjected to an axial pull of 10 kN. So there is a rod, circular rod. Rods generally made in circular cross section. So here circular rod subjected to axial pull P, axial pull P. So here axial pull, how much is given? Axial pull. So P is equal to, given 10 kilonewton, 10 kilonewton. So there is a rod, okay. So this rod subjected to axial pull. So P is equal to 10 kilonewton, okay. So 10 kilonewton is apply chestam axial ga man, okay na. That too it's a pull force. So it will elongate. Obviously it will elongate in loading direction or axial direction, okay. So axial pull of 10 kilonewton and the change in diameter was observed, okay na. So due to pull there is a change in length in longitudinal direction. Along the length there is a longitudinal strain, okay na. Change in dimensions in longitudinal direction, okay na. The two change in length in longitudinal direction and change in diameter in lateral direction. So perpendicular ga emutundi diameter అనేది change అవుతుంది. So generally due to axial pull diameter decreases, okay na, length increases, diameter decreases and length increases. So diameter emo decrease అవుతుంది, length emo increase అవుతుంది due to axial pull. So anyhow here change in diameter is equal to 3 into 10 to the power of minus 3 mm. Change in diameter is 3 into 10 to the power of minus 3 mm. Calculate Poisson's ratio. So anyhow ultimately we need Poisson's ratio denoted by nu or 1 by n, and next we need modulus of elasticity. Modulus of elasticity. Modulus of elasticity denoted by capital E. So manaki nu kavali, e kavali, okay na. These are the conditions, okay. So there is a rod subjected to axial pull of 10 kilonewton and diameter of rod is how much given? Given 10 mm, and shear modulus or modulus of rigidity also given. So now first of all let us find modulus of elasticity and Poisson's ratio. Anyhow first of all we have to think, okay na, what is the relationship between shear modulus of rigidity, Poisson's ratio and modulus of elasticity. So in elastic constants concept, G is equal to shear modulus or modulus of elasticity is equal to E by 2 into 1 plus mu, okay. So this is the relationship between G, E, nu. So G ki, nu ki, E ki relation into, so G is equal to E by 2 into 1 plus mu. So anyhow transpose 2 into 1 plus mu, then E is equal to, division becomes multiplication, 2z into 1 plus mu. E is equal to 2 into, so what is the value of G? 0.51 into 10 to the power of 5 into 1 plus mu. So E is equal to 2 into 0.5. So if you calculate, you will get 1.02 into 10 to the power of 5 into 1 plus mu. So E is equal to 1.02 into 10 to the power of 5, again you will get 1.02 into 10 plus 5 distribute. Okay, so 1.02 into 10 to the power of 5 into 1, 1.02 into 10 to the power of 5. 1.02 into 10 to the power of into nu, 1.02 into 10 to the power of 5 nu. Okay, this is the relation between E and mu. This is equation 1. Let us say this is equation 1. So again, is there any other relation between E and mu? So is there any other relation? So actually, so what is Poisson's ratio? Poisson's ratio nu is equal to lateral strain by longitudinal strain. Lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So in general, whenever a rod subjected to axial pull, so we get the strain in longitudinal strain in axial direction. Okay, so along the length we get a longitudinal strain. Along diameter, I mean in perpendicular direction or lateral direction, we get lateral strain or diametral strain. So lateral strain is also known as diametral strain. Okay, so diametral strain means change in diameter by original diameter. Okay, so along length ఏమో longitudinal strain వస్తుంది, change in length by original length. అదే మనకి along perpendicular direction, ఓకేనా, perpendicular direction lateral direction లో మనకి ఏ టైప్ ఆఫ్ strain డెవలప్ అవుతుంది, diametral strain. ఓకేనా, change in diameter by original diameter. Okay, anyhow Poisson's ratio formula lateral strain by longitudinal strain. Okay, so now Poisson's ratio is equal to lateral strain by longitudinal strain. So Poisson's ratio nu is equal to lateral strain denoted by epsilon d and longitudinal strain denoted by epsilon n. So we know that according to Hooke's law, Young's modulus is equals to stress by strain. So here anyhow here rod subjected to axial pull. Okay, we get longitudinal strain. Okay, so longitudinal strain and diametral strain. So Young's modulus is equals to stress by normal strain. Here normal strain is along normal direction. Okay, so we get longitudinal strain. So again, what about epsilon d? Epsilon d means here epsilon d means change in diameter by original diameter. Change in diameter by original diameter. Change in diameter how much is given? 3 into 10 to the power of minus 3 mm. By original diameter 10 mm. So you will get 3 into 10 to the power of minus 3. Okay, na? So 10 to the power of minus 3 into 1 by 10 can be written as 10 power minus 1. So overall you will get 3 into 10 to the power of a power m into a power m plus n minus 4 m. So sorry. So anyhow mm, this is mm and this is also mm. Mm get cancelled. So diameter strain has no units. It has no units. Diameter strain units e undavu. Next, and what about longitudinal strain? So from this formula, longitudinal strain can be written as sigma by transpose E. Okay, na? Here you can take 1. Okay, na? So coefficient as 1, transpose E. Okay, na? Multiplication becomes division, sigma by. So again, what is sigma? Okay, what is sigma? Before that, so we have epsilon L is equal to sigma by E, and here we have epsilon D equal to 3 into 10 to the power minus 4. Substitute epsilon D and epsilon L in this formula. Now Poisson's ratio is equal to epsilon D value 3 into 10 to the power of minus 4 by epsilon L means sigma by E. Reciprocal of sigma by E, E by sigma. So 3 into 10 to the power of minus 4 E by sigma means strain. So strain formula load by area. Strain is equal to load by area. So mu is equal to 3 into 10 to the power of minus 4 into E into P by A, reciprocal of P by A by P. So A by, so load how much given? 10 kilonewton means 10 into 10 cube newtons. Mu is equal to, so if you simplify this, how much you will get? You will get 3 into 10 to the power of minus 4 into E into A by 10 into 10 cube, 10 power 4. 10 into 10 cube, 10 power 4. And here A means area, cross-sectional area of the rod. Here A means cross-sectional area of the rod. So for circular cross section, what is the area? So pi by 4 into d square. Okay na, area of circle pi by 4 into d square. Pi by 4 into d square by 10 to the power of 4. Mu is equal to, so 1 by 10 to the power of 4 can be written as 10 to the power of minus 4. So into 10 to the power of minus 4 into E into. So diameter how much he given? He given diameter 10 mm, so 10 square. Okay. So anyhow, finally here you will get mu is equal to 3 into 10 to the power of minus 4 into 10 to the power of minus 4, 10 to the power of minus 8 into E into pi by 4 into 10 square, 100. Okay, or you can write directly 10 square here. So mu is equal to 3 into 10 to the power of minus 8, 10 square. So a power m into a power n, a power m plus n, minus 8 plus 2 minus 6 by 4 into pi, okay, into E. So if you simplify this, first of all pi by 4 how much? Pi by 4 value 0.7854 into 3 into 10 to the power of minus 6 E. Okay na? So if you simplify this using scientific calculator, you will get 2.3562 into 10 to the power of minus 6 E. So this is one more equation, okay na, between among mu and E, Poisson's ratio and Young's modulus. This is equation 2. Okay, so equation 1 already we have equation 1. So let us solve equation 1 and equation 2. Okay, first of all let me write what is equation 1. Then we can solve equation 1 and equation 2 to find. Then we can find mu and E. So already మనకు ఒక ఈక్వేషన్ వచ్చింది in terms of E and U. అలాగే ఇది ఒక ఈక్వేషన్. ఈ 2 ఈక్వేషన్స్ సాల్వ్ చేస్తే మనకి ఈ న్యూ ఈ వాల్యూస్ అంటే పాయిజన్స్ రేషియో యంగ్స్ మోడ్యులస్ వస్తాయి. ఓకేనా, సో ఇది బేసిక్ కాన్సెప్ట్ ఇది. సో 2 ఈక్వేషన్స్ ఇప్పుడు సాల్వ్ చేయాలి ఇక్కడ. ఓకే, సో దిస్ ఈజ్ మై ఈక్వేషన్ నెంబర్ 1 అండ్ దిస్ ఈజ్ మై ఈక్వేషన్ నెంబర్ 2. ఓకే, సో దిస్ ఈజ్ ఆల్రెడీ వి గాట్ దిస్ ఫ్రమ్ elastic constant relation. G is equal to E by 2 into 1 plus mu. Before only we derived this equation. So E is equal to 1.02 into 10 to the power of 5 into 1 plus mu. Okay na? So we got this equation from G is equal to E by 2 into 1 plus mu relation. Okay, formula. So let us solve these two. So first of all, here E is equal to, so 1.02 into 10 to the power, transpose 1.02 into 10 to the power of 5, multiplication becomes division. You will get E by 1.02 into 10 to the power of 5 and at last you will get 1 plus mu. So if you simplify this 1 by 1.02 into 10 to the power of 5, you will get approximately 0.9804 into 10 to the power of minus 5 into is equal to 1 plus mu. And again here, so observe here 0.9804 10 to the power minus 5 E. So in LHS we have unknown E and also in RHS we have unknown mu. So from equation 2, look at equation 2. So equation 2 lo manaki mu in terms of E undi kada. See, mu in terms of E. So just I want to convert this entire equation in terms of E. So in place of mu we can take 2.3562 into 10 to the power minus 6 into E. So replace mu 0.9804 into 10 to the power of minus 5 into E is equal to 1 plus, replace mu by 2.3562 into 10 to the power of minus 6 E. Okay. Now transpose this term to the left hand side. Positive term becomes negative term. 0.9804 into 10 to the power of minus 5 E minus 2.3562 into 10 to the power of minus 6 E is equal to 1. So here what is the common thing? E is common. Take out E as a common factor. So E common this thing 0.9804 into 10 to the power of minus 5 minus 2.3562 into 10 to the power of minus 6. into okay, no, sorry, already we have E is equal to 1. Okay, so let us simplify this. Okay, then we will get E value. So if you calculate this value, you will get E into 0.000, I got 5 zeros 74478 is equal to 1. Transpose this value, you will get 1 by 0.000074478. If you calculate this again, you will get E value. So you will get E value approximately 134.267. Okay, 134. Actually, you will get 134.267 approximately Newton per mm square. Okay, now all units, we maintain all units in newtons and mm squares. Okay, mms. So anyhow, E is equal to, it can be written as 134.267 kilonewton. Okay, now so let us move decimal point 3 places from right to left. So 1, 2, 3. You will get into 10 cube. 10 cube means kilo. So kilonewton per mm square. This is the value of Young's modulus of the given rod material. So given rod material ichchado, that Young's modulus is E is equal to 134.267 kilonewton per mm. What about Poisson's ratio? From equation to nu is equal to, from equation to, what is nu? 2.3562 into 10 to the power of I think 10 to the power of minus 5, I think so, minus 6, sorry, minus 6 into E. Okay, so nu is equal to 2.3562 into 10 to the power of minus 6 into, what is the E value? What is the E value in terms of Newton per mm square? 134.267 Newton per mm. Okay, actually units, okay, fine. No need to write units here because nu has no units. So finally nu is equal to, if you multiply, you will get final value as 0.316. So what is the value of Poisson's ratio? Poisson's ratio equal to 0.316, and we got Young's modulus 134.267 kilonewton per mm square. And this procedure. So this type of models ichi E and U find out cheyamante Young's modulus of elasticity and Poisson's ratio find out cheyalante ee procedure follow avvali. So suppose in question given modulus of rigidity and change in diameter, original diameter. So these 3 quantities ichi find Poisson's ratio and Young's modulus ante ee procedure follow avvali. Solve cheyalante problem.